Hello everyone, I am here today with another Leetcode practice video. Once again, I've picked a random problem that I haven't done before, and I'm going to spend about the next 30 minutes working on it and going through my thought process while I write the code and figure out this question. So let's get started with the question. You are given a string S consisting of the following characters: open parentheses, close parentheses, open and close bracket, curly brace, and open and close bracket. The input string S is valid if and only if every open bracket is closed by the same type of closed bracket, open brackets are closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. I want to return true if S is a valid string and false otherwise. So in our first example, we just have one set of brackets, and this would return true. In the second example, we have a series of nested brackets with curly brace in the inside, regular brackets in the middle, and parentheses on the outside. And this would also return true. And finally, we have this example: open bracket, close open parentheses, and then close bracket, and then close parentheses. And in this case, we would return false. So the rule that this input broke was that the brackets were not closed in the correct order. From what I can see here, because the most recent open bracket parentheses curly brace was a parentheses, in order to close it, we would expect a closed parentheses. But since we met a different closing character, it would return false. So let's take a few notes about this problem. The input is a string that only consists of brackets, parentheses, and curly brackets. The output is just true or false. And when do we return true or false? We have three rules. Every open bracket is closed by the same type, which means parentheses close parentheses, brackets close brackets, curly braces close curly braces. Next, all open brackets are closed in the correct order. So something like this is fine, but this would not be fine. And finally, every closed bracket has a corresponding open bracket of the same type. So if there's a parentheses, it needs to be preceded by an open one. We can't have something like just a single closed bracket or parentheses, and even if everything to the left of this was true, there's nothing that closes this. It would still be an error. Some other constraints I want to take a look at is the length. As we can see, we will always have a length of 1, so we won't have to deal with an edge case where we have an empty string. Okay. With that being said, I think we can start looking at some algorithms for this. I think this problem is pretty straightforward in that it will require a stack, just because of how things will need to be organized, and taken away, and just like how the order that they need to be closed in. Stacks are last in, first out. And this will result, and this mirrors the type of behavior that we want in this problem. If we currently have an open bracket, an open parentheses, and then we see an open bracket of a different type, this one is now on the top of the stack. And what we're looking for in order to remove this element from the stack is a corresponding bracket. But essentially what we need in order to remove items from the stack is whatever corresponds with what's at the top. So something like a queue, which only takes in from the front and exits at the back, is not the right data structure for this problem. As for other algorithms, I suppose if we tried to, say, brute force it, like perhaps use a two-pointer approach. Let's say we didn't want to use any data structures at all. And then let's say we let's say we just iterated through the string as if it was a list and just kept track of what we currently had. I suppose in order to keep track of anything, we would need to have some type of data structure. So maybe a two-pointer approach wouldn't work here. But either way, if we were to try to iterate through the entire string and make sure every character matched all of these rules, we would save on space complexity, but we would increase time complexity dramatically. So that wouldn't be the right approach for this problem. Now, implementing it with the stack, though, would be pretty straightforward. And here's how it would go. If we see an open bracket, an open symbol, we would add it to the stack. If we see a closed bracket, then here's what we do. If the item at the top of the stack, well, if the item at the top does not match, or the stack is empty, then we return false immediately. If the item does match, say we see a closed bracket and then the top of the stack is an open bracket of the same type, then we remove or pop from the stack. So we would remove the element that's currently at the top. And so we can take a couple examples here. Let's say this is our string. We see an open curly brace. So this is what our stack would look like. First we'd catch the open curly brace, and next would be the open parentheses. After that would be the open bracket, and at this point we've only seen open symbols. But next we'll see our first closed one. It will be a closed bracket, and now we check the top of the stack, which is the open bracket, and because this is the same type, we will pop it from the stack. So our stack now becomes this. At this point we are now looking at the fifth element, which is a closed parentheses. The top of our stack is an open parentheses, so we would pop that too. And finally, we would repeat this process on the curly brace. We would see the closed curly brace, check the top of a stack for an open one, and pop that from the stack, giving us an empty stack. Now that this sequence of characters is done, we would continue and find another open bracket and add it to the stack. We would continue on and find a closed one. We would verify that it is the same type, and we would pop. And once we've traversed through the entire string and our stack is empty and we didn't run into any issues while traversing the string, and of course because our stack is empty at the end of the string, we know that we don't have any unclosed brackets. So that will be our requirement for returning true. After finishing the loop, if our stack is empty, return true. Otherwise, return false. So here's our plan. We would loop through the characters in the input string, add open brackets to the stack, pop from the stack if we see the closed bracket of the same type, or return false if they are a different type, or if the stack is empty, and then return true or false based on whether or not our stack is empty. Alright, now I can get started with the implementation. For Python, I believe Python has some type of stack import. If not, I may have to refresh myself on the specific syntax and terminology. I would just look at the documentation. Oh, never mind. It appears that the stack just uses something very similar to uses essentially an array. At least that's the implementation that is shown. I wonder if Python does have a stack library though. Okay, I suppose we wouldn't need to worry about that right now. We'll just continue using the list to solve this problem. So let's use the list. And then for each character in this string. If C matches one of the open brackets, I think we can assume for this problem that all of this that the string will be a valid input. Not valid in the sense of what the problem is asking for, but valid in the sense that it will only contain those following characters. It won't contain a character other than open and close brackets, so rather than using an else if condition and trying to be careful with how we filter, I think we can just assume that if the character isn't an open bracket, that it's a closed one. So to appending for a list places the item at the end of the list, and I believe popping will remove the element at the very end of the list. So I'll be using the append and pop functions for this problem. So we do want to make sure okay, if we say close bracket, we check the top of the stack. If the item at the top does not match, we return false. But if it does match, we pop it from the stack. Now, we return true if our stack is empty. Okay, let's try giving this code a run. Okay, so I did run into some... Oh, okay. Yeah, a list object in Python doesn't have a peek attribute, so I can't just use this. Since I am implementing the astack using a list, the best way to index the very end of it would just be to use -1. Let's try that again. I see. Maybe this part is wrong. Okay, there's something else going on with this problem. Let's try this again, but make sure we print out each character. And print out the state of the stack as well. Okay. So it seems like the character was read correctly and appended to the stack correctly. Okay. No, this is my bad. This was not the right matching algorithm at all. Matching approach at all. I can't just... The stack only contains open elements. I can't just compare a closing one to an open one. So... let's say, what name should we give the top of the stack? Let's just call it top. We'll set it to the top of the stack, and then we'll make sure if the top is an open bracket and C is a closing one, or, and then we'll repeat this process with the other two types. So open parentheses and closing one, and open curly brace and closing one. Now let's try that again. And that would be, I think we've solved this problem. Let's try it with all the rest of the test cases. Okay. No. This is one more edge case that I needed to cover. What happens if I read a closing bracket, and there's nothing in the stack at all? If we try to index the stack, it will give us an index out of range error. So every time we check, every time we read a closing bracket, we need to check if the length is not 0. If it's 0, we return false right away. So let's do that. And that would be the solution for this problem. Let's take a look if it matches the other ones. Okay, so there is a brute force method that doesn't use, that does not use a stack. This method would just repeatedly remove matching pairs until nothing is left. I see. Yes. At some point in this string, if it is valid, there will be always be a part where an open bracket and closed bracket meet, and they're of the same type. And so what the brute force method does is it will constantly go through the string however many times is needed, and it will replace them with nothing. And then if you had, say, this situation, first it would look at any points where brackets are meeting, and it will close and it will end them, remove them. So this would be removed, and then this would be removed. It would go through the string again, and then remove this one, and then go through the string a third time and remove the last one. And that will still be an O of n in space complexity because of the space that a string takes up, but it will also be squared in time complexity, which is far too inefficient. The method that I used is a stack. So as the algorithm states, we would create a stack, store open brackets in the stack, and then pop from the stack if we read closing brackets. This seems pretty straightforward. Ah, I see.
You need pots or pans. Everything.
So, yeah, this approach does use a cleaner way of writing this. It creates a dictionary and then assigns each open bracket to the corresponding closed bracket. That way, like figuring out which one we need is a lot simpler, and we wouldn't need to repeat the same code 3 times.
There's the pan.
Okay, so that will be it for today's problem. Thank you very much for watching. I hope you have a great day.